Hi, Roy from Tulip here, and today I want to show you how to use our data collection app to create a data set that you could use for machine learning and computer vision. You could then use the data set for automatic defect detection right within Tulip. In this very simple app, what you get is a view from the camera and two buttons for annotating the image for pass or fail. First, we should make sure that our camera widget will show the view from the correct camera. This is my visual inspection camera. We should also verify that our camera assignment in the capture triggers is directed at our inspection camera. So if we look at the trigger here, we can see that I'm using my inspection camera. You could also specify a region from which you want to capture the image in case you want to focus on a smaller area and only run the detection on that part. So I'm actually going to put region 1 here to only capture images from the red marked region of the image, which I have defined in the vision configuration screens. If you leave this empty, it will take the whole image as a sample. So I simply put something under the camera and hit one of the buttons to collect a sample of that object and annotate whether it was correctly manufactured or not. Once you're done collecting, you can take all of the images and run a machine learning detection algorithm that could replace your manual visual inspection step. What you see here is how the app looks in the app editor, and on the bottom right, you can see how it runs in Tulip Player. Again, just one simple page, one simple process in which you could click buttons and start collecting some data. I have a very simple setup here in which I could put a PCB under this microscope camera that looks at a particular area of this board for the ISP connector here in the end. What we're going to do with visual inspection is see if that connector is okay or if it's damaged. So with this board I have here, the connector is actually okay. I have a different board here with the connector damaged. This application will allow us to do some close-up visual inspection and decide if this part is a pass or fail. You can set this up as a quality inspection station and collect the data there. I'm going to put this board under here and start collecting some images. First, I would say that this is a pass. And then just shift around so that we have some variation in the way that we put the board in the placement jig. It is very important to have a placement jig so that all images of the same area of the part. Feel free to move it around so that we get some more variation. As you see, when I click, I get more and more of these samples collected in my Tulip table there to the right. We will want to get about 10 images at least from each one of these conditions, the correct and the failure case. Now that we have roughly 10 correct images, let's capture some failed ones. You see that the pin here has been pushed in and it's damaged. So again, I'm going to put the board here in various positions, moving it around and simulating what may happen on the floor when you put the part in for inspection. We'll just take a picture of that part under the same view and collect it in our Tulip table. All right, so we have about 20 samples all told. And now if we switch to our Tulip table, we can see all those samples have been collected along with their annotation. One sample has one annotation. They're a little bit different, and what we want is for the machine to learn the difference between normal and anomalous or defective part. So this is our simple, basic data collection application. Watch out for other guides on how to take your data set and apply it to automatic visual inspection. Thank you.